of you, and apart from that, I would try to keep it simple so that everyone can understand. So Dr. Anwar has already introduced myself in detail. So the area of my interest includes signal processing in radars, MIMO and phased array radars, optimization, software-defined radios, multi-antenna radars, wireless communications, and wireless propagation. Uh, I was awarded US patent in radar deception jamming prevention. Apart from that, as Andrew said, that research productivity award, Young Leaders Development Award. I was also the topper at radar systems module at University College London. I have worked with different strategic organizations, and apart from that, I have worked with Professor Hugh Griffiths at University College London and at his radar group. So since I want to keep the thing simple, so let me start with the basics of what a radar is. So radar basically works on a basic principle of listening to an echo of the transmitted signal. So you can see a transmitted signal. A monostatic radar here means a kind of radar that has only a single antenna. It transmits a signal that strikes a target that comes back, and by that, it figures out not only the range of the target, but also the speed of that. Now, as far as the range is concerned, the time is important, that how much is the time span, and from that you can figure out the distance. But as far as the speed of the target is concerned, you have to figure out the frequency, and that frequency is Doppler frequency. So you can see over here that there's a transmission of signal and the reception of its echo. The time taken by the signal to return, which is called the time delay, is used to estimate the distance of the object, as I said earlier. And for the moving object, the frequency of the received signal is different from the transmitted frequency, and that is used to estimate the radial velocity. So I'm focusing on that since this is more important, concerning that the title of my topic is related to micro Doppler. So right now I'm talking about Doppler frequency. So if the target is moving, it will create a Doppler shift, and by that you have to figure out the velocity of the target. Whenever you talk about the radar, the first thing that comes to your mind is it may be an airborne radar, it can be an over-the-horizon radar, it can be a huge weather radar, or it can be a huge ground-based radar. So whenever we talk about the radar, the first thing that comes to our mind is gigantic structures, right? So that is not always true. You know, the world is getting smarter, and the radars are actually replacing the sensor as it brings smarter functionality. So in the modern day world, when we ever see the radars, so the radars are like shorter and smarter sensors. So they are in our homes, on highways, with Doppler radars, and in community buildings, radars are working as smarter and shorter sensors. So whenever you talk about radar, it does not necessarily mean a big gigantic structure. Now, coming to the important subject, which is the micro Doppler. So I've just talked about the Doppler right now. So now I'm going to talk about what a micro Doppler is. So the object's bulk movement is sometimes complemented with periodic vibrational or rotational movement, which is called as micromotion, which creates sideband Doppler frequency shifts about the carrier frequency, called the micro Doppler effect. So the structural components of each object generates a distinctive pattern of frequency shifts, also called micro Doppler signatures, used for identification of the object, right? So let me make it a little bit more simpler, right? So whenever we are walking, all of our body is moving, but also our limbs are also moving. So that limbs are also generating a micro Doppler, right? So limbs are important over here, right? What are the sources of micromotion? So you can see a human articulated motion, that is walking, running, respiration, heartbeat, etc. Right? So rotating propeller, rotor blades, rotating tires, these are all creating micromotion. So yes, the car is moving, right? So the car will generate a Doppler effect, but its tires that are also rotating would create a micro Doppler effect. So you can see a small mini drone over here. So what that drone is creating, so that drone is basically, whenever that drone will move, it will create a Doppler effect, and by that you can figure out the frequency of that. But the rotating propeller, what the rotating propeller would do, that would create an additional frequency component, that is basically the micro Doppler. Now coming back to another example, you know, the flapping wings of birds, right? So the birds are flying, so it will create an effect of Doppler, but the corresponding wings of the birds would create what? that would create the corresponding micro Doppler effect. So similarly, the surface vibrations. The vibrations would also generate, the corresponding micro motion. So when we talk about the radar, so how we can extract the micro Doppler signatures, right? So first of all, the micro Doppler is acquired, and then there's a time frequency analysis, and then you have to go through the corresponding micro Doppler signature classification, and by that you can figure out the corresponding target. Okay, so micro Doppler fundamentals. If the radar transmits a sinusoidal waveform of frequency, say f naught, the reflected signal from a point scatter will be given by something like this. So the rho is the reflectivity function of the point scatterer, and the phi is the time varying phase of the received signal. Now that phase is very important over here, because the corresponding movement of the target would modulate the corresponding phase in a way that whenever you take the time derivative of phase, we can find the Doppler frequency. So that Doppler frequency, when analyzed closely, would create a Doppler shift due to translational motion. So what is the translation motion? The bulk movement is the translation movement, right? And what is this thing, micro Doppler, which is created by the additional frequency component or the non-rigid part of the body or the object that creates the micro motion, that would create a micro Doppler effect to that. Okay, so for vibration, since the amplitude of the movement is sinusoidal, the received signal is, I'm not going into the details of the mathematics. So as a simply stating, the theoretical analysis indicates that the motion of an object modulates the phase function that would create sidebands, and the modulation that would be centered around the Doppler frequency. So there would be a Doppler frequency, and centered around that Doppler frequency, there would be sidebands that are basically created by the micromotions. Therefore, the micro Doppler consists of spectral lines around their center frequency of f0. Okay, so now coming to this point again, for the vibration part, since the vibrations correspond to a sinusoidal movement, right? So the resultant Doppler frequency would have a sinusoidal component in that. So if we plot the micro Doppler effect in that, so that would be something like a sinusoidal wave, right? Okay, now time frequency analysis. Why we need a time frequency analysis? The instantaneous frequency is useful for a single frequency value at a time, and it is not useful for several oscillating frequencies. So since this is a special case, this is not a conventional thing, micromotion, right? So if the spectral composition of the signal is time varying, conventional Fourier transform will not work. So we need a joint time frequency analysis, and for that we need spectrogram. So conventional Fourier transform will not work over here. So this is very important. Whenever we talk about the Doppler, micro Doppler, instead of Fourier transform, we talk about the short-term Fourier transform, right? So in short-term Fourier transform, there is a window function. Instead of taking the whole signal and taking its Fourier transform, you take a window function, and that subdivides the corresponding signal so that each of the window function is LTI system, and then the whole system is integrated, and then the complete Fourier picture or the frequency domain picture is received, right? So that is a short-term Fourier transform. Okay, so measurement of micro Doppler. So now coming back again to the same thing that I stated earlier, that whenever we talk about the radars, we talk about something or huge structures. So can we do something like that in a laboratory environment, in academia, or as a low-cost solution to something? The answer is yes. So software-defined radios have been used greatly of late in different institutions, also in industry. So they are pretty useful, software-defined radios. So you can see a picture over here. The thing that is important over here is that the use of micro Doppler signature actually has a few advantages for the target classification as compared to the conventional approach. Firstly, the processing time is lower. And secondly, because there is no strict requirement of the range resolution, that is why the requirement of the bandwidth is not that huge. And since the requirement of the bandwidth is not that huge, this is something that can be done in a low-cost environment. Okay, so micro Doppler signature captures unique characteristics of an object and its micromotion that serves an object's identity. Why we are talking about signatures? Because that becomes a unique characteristics of an object. Typically, it is a frequency modulation represented in time and Doppler frequency domain. Micro-Doppler signatures are used to identify different objects and their motions or actions. So you can see this figure, and you can see this in detail. On your left, you can see the STFT plot of a human that is walking. In the middle, you can see a STFT plot of a dog, and on the left, you can see a STFT plot of a horse. So you can see that all of these are different, because the way a human walks is totally different from how a dog, moves, or a horse moves, right? So all of these plots are different. So the signature of each of them would be different. Now, coming to the next topic, which is next example, which is the micro-Doppler for human arm movement. So whenever we are walking, as you can see in the figure on your left, so if you're walking, even if you are walking very slowly, so our both limbs would also be moving with that. Since both of our limbs would be moving, so you can see a plot like this. This slide is actually very important. It would actually clear your concepts as well. Now, on your middle, you can see that this is the STFT plot of a human that is walking with one arm. So you can see that is this sort of clipping of waves over here, right? So in that, we can see both the waveform can show that it is going on both of the sides centered at that corresponding Doppler frequency. Whereas we can see that the peaks are clipped because only it is moving with a one arm. So by that, we can figure out if someone is walking, for example, in a prohibited area with, you can say, a weapon or something like that. So you can figure out that it is moving with one arm. So one of its arm is static. So this is a plot of a human again that is walking, but it's walking without the movement of its arm. The arms are just stick to the body. So it is not giving us a vibrational movement with that. So only it would be centered around some Doppler frequency, but there is no micro Doppler associated with that. Okay, so micro Doppler for drone and bird. So on your left, you can see this is a fixed wing drone. Obviously, drones have so many types. So this is a fixed wing drone. So in the fixed wing drone, you can see it's STFT plot. In that frequency is on the x-axis. It looks something like this. But on your right, you can see a bird that is a duck that is flapping its wings. So whenever it's flapping its wings, so it is creating a sinusoidal sort of a STFT plot. So this is very important, right? So it would have a different signature and it would have a different signature. And that is what I'm trying to highlight, that is that the micro Doppler effect actually is very useful in identifying the corresponding signatures. Okay, so this is the micro Doppler signature for a pendulum. You can see this is a pendulum that is going to and fro movement. So you can see that the micro Doppler signature of an oscillating pendulum looks something like this sinusoid. Now, this is a damped pendulum, so it is damping with time. So since it is damping with time, you can see this corresponding Doppler is actually converging to zero. So you can see a walking human and the corresponding micro Doppler signature. So as it is moving, it is creating a sinusoidal pattern on both of its sides. And since this is walking towards the corresponding radar that is detecting it, so you can see a more pronounced peaks on one side than the other. This is very interesting. Apart from that, so many micro Doppler applications, detection of space target, recognition of air targets, recognition of ground moving targets, detection of survivors trapped in a rubble to the wall micro Doppler radar. So these are also very, very important, topics. For example, detecting the vital signs and finding trapped survivors is another important application, as you can see over here. So although the survivors trapped in rubble cannot move, but they can still have a micro motion. For example, they can breathe. Also, they would have a heartbeat, right? So radar is able to penetrate the rubble, and that is the beauty of radar. So it is possible to detect the vital signs by detecting and analyzing micro Doppler signatures of the survivors. And again, a very important application of micro Doppler. Again, something that would be very useful for students, if there are any that are listening to me, for their research areas in the future. Okay, so now I'm coming to the next part of my talk, which is particularly focused on drones, and that is a micro drone. I'm not going to talk about drones that are big drones. Rather, I'm talking about mini drones, hobbyist drones, or drones that are used for leisure activities. So this is very important. In recent years, the number of small UAVs that are available to civilian users has largely been increased. Most important reason that it's low price. Everybody can afford to have a small drone. Moreover, that is very simple to use. You don't need a training for that. The kids are making use of that and flying those small objects, and they are being used for filming purposes. Also, if I talk about the wedding, especially if I talk about weddings in Pakistan, from the last few years, the use of micro drones for filming purposes has been very common. Apart from that, for leisure activities, the use of micro drones has increased a lot. Micro drones have, uh, playing a part in the area of agricultural sector. In the area of agriculture, there's a lot of use of micro drones. I'm going to talk about that separately as well in coming slides as well. Also, you must have heard about the parcel deliveries using the micro drones in the West, especially. And of course, micro drones can be used for the search and rescue operations. So, yes, micro drones are extremely important and beneficial, and they're turning out to be very useful and a handy object for in so many areas. So you can see the drones, small drones. Okay, so micro drones in agriculture sector. So micro drones have been used in the agriculture in the past, but that trend has gradually been increased, and it has led to something known as intelligent agriculture. So a huge area, for example, the 20 hectares of area that can be covered by a farmer, and it can take like 15 days. But in case if it will not only save the energy, time, pesticides, and cost, so there's a huge advantage of using micro drones in agriculture sector. If I just talk about China, in 2018, small drones are used for 3 to 5% of farmland. So this number is quite huge, right? Coming to the next, micro drones in oil sector, right? So the Sinopec, this is one of the world's largest oil refining companies. It uses drones for inspecting its pipelines in southern China, right? So since 2017, I mean, from the last 4 or 5 years, the total traveling of the drones has surpassed 40,000 kilometers. That is a huge distance that the drone has covered from the last 4 years that the drone has covered, and it has covered that distance in order to inspect the corresponding pipelines. So again, I've talked about China in that case, and the reason for that is that almost 80% of the commercial market has been covered by the Chinese only, right? Okay, so the commercialization of drones has granted the public with unprecedented access to unmanned aviation as well. So although I've talked about the benefits of that, but they're associated negative side of that as well. So of course, this is unprecedented access of UAV aviation to public in general, which is not good, and that is why there is a high demand to mitigate the accidental or voluntary misuse of these platforms. The use of micro drones can lead to antisocial activities. It can be used for privacy violation or collision hazards. Obviously, they have collision hazards with other aircrafts. It can be used for transportation of illicit materials of explosives. So, of course, there's a need to mitigate such issues. Okay, so uh, there are challenges associated with detection and tracking of micro drones. So, detection and tracking of UAVs with radars, it is poses significant challenges, as small UAVs typically have a low RCS. So RCS is basically a measure of the corresponding size of the target. The greater the RCS, the bigger the object would be, and the lower RCS, the corresponding smaller would the object would be, and by that, the corresponding detection of the target would also be very difficult. Apart from that, they fly at very low speeds and altitude as compared to conventional aircraft. So, conventional radars would not be beneficial in that case, although they would be detecting something which is very less in cost as compared to, the real threat. But this low cost equipment, even then, it can turn out to be extremely dangerous, right? Apart from that, small UVs, are capable of highly varied motion, such as hovering, uh, which complicates the task of separating them from a stationary clutter. Also, the high maneuverability of small UAVs make the tracking problem more difficult, as it is not possible to make a strong assumption about the expected UAV motion that typically a radar does. You can see that this is a drone, and doing strange kind of acts. So from these, we can see that there are huge hazards. So I'm going to give an example of Gatwick Airport. Back in December 2018, two small mini drones were seen at Gatwick Airport, and since they were not authorized, there was a lot of chaos because of that. 33 hours closure of a busy airport that led to 1,000 flights that were being cancelled, and 140,000 passengers got affected. If I'm not wrong, it took about 18 months to conclude the corresponding, details or for that event, and it took 800,000 UK pounds to the British government. This is a huge loss. The loss because of what? Of something that is extremely cheap. So yes, the hazards are huge. The hobbyist drone greater than 2 kg, obviously 2 kg is not a big number at all. It can break the cockpit of an aircraft, right? So although something can be unintended, but that can lead to a huge chaos, right? So yes, there are benefits of that, but at the same time, there is a need to formulate and design radars that can detect that, and hence save the corresponding society from the associated hazards of that, right? So as I said earlier, that in the academia, small software defined radios can be used, uh, and since the micro Doppler effect is it does not have those stringent requirements that a larger radar usually requires. So that can be done in a laboratory environment, in academia, and in industries that are low cost industries. Okay. Now, as far as detection, micro Doppler detection and SCRs are required, I'm not going into detail of that. So there is some problem with that. So the problem is that the micro Doppler signature with the target aspect angle, which is an additional challenge during the detection process. So this is something we need to look at. So we have to choose a device or the corresponding SDR that can suit the corresponding type of micro Doppler effect, right? So there are so many issues with that. For example, micro Doppler classification requires large amount of data to be recorded, which demands interference-free hardware. So we have to ensure this thing, right? So we have to ensure that the hardware that we are using is interference-free. Given that our hardware is interference-free, then the things would turn out to be very easy. The question that would be coming to your mind is that are there any examples of that are being used in academia and industry? So I've taken two examples, one from academia and one from industry, in order to show you that yes, it is being implemented, and a lot of research is being done world over in this particular area. So there is a NetRad radar that is developed at the University College London. Again, this is something all of the work has been done mostly in a laboratory environment in an institute or academia. So Lots of promising results were achieved back in 2015, and they're still, working, trying to make it better. And it not only detects, the corresponding small drones, but also it can capture, walking, gating. It can be successfully captured, and also it can be used for recognizing individuals and determining whether they are armed or not. The corresponding example that I gave earlier. One example from the industry, that is a steering radar. So I've also seen that radar back in 2019 at Cambridge, UK, at the Evilent company, right? So they use a transmitter that uses a vertical stack of 8 antennas. So that Evilent's holographic technology is proving to be very effective, and that is being used for detecting small drones. So that Gamekeeper radar is based on a 2D 16 to 4 array of receivers, and it allows radar to continuously steer in all directions. So it is able to process echoes by forming simultaneous beams that cover the entire search volume. So it is being used for detecting small drones. And by that, I would conclude. I would like to thank you once again. And by that, I would also again, I've shown the the flag of
Yeah.
Turkey, and the reason being is obviously Turkey is, it's in the heart of every Pakistani these days. Especially, I would like to appreciate the role of Turkey in uniting the Muslim community, and the ongoing issue of Palestine. And let me assure you that every Pakistani just loves Turkey these days. Especially these days, the Turkey and Pakistan are like gelled up with each other. And with that, I would like to thank you. Thank you very much for inviting me. Indeed, it was an honor, and thank you very much. And thank you.
Good luck. Thank you very much for your very productive and well detailed talk. It was very useful, at least for me. I think so. I'm not working this area, but I think I understand much of them. So we would like to have a question right now, if it's okay for you, Dr. Farhan.
Yeah, sure.
Yes, please go ahead. Eğer bir sorunuz varsa hocam, değerli hocalarım, arkadaşlar. Any question please?
Enver Hocam, benim sorudan ziyade Farhan hocamıza çok teşekkür ediyorum. Çok değerli bir sunum yaptı. Buradan kardeş Pakistan'a da selamlarımızı, saygılarımızı gönderiyoruz. Gerçekten iki ülkenin geçmişten gelen bir tarihi bağı var. Bizler için önemli bir ülke. Hocamıza sunumundan dolayı çok teşekkür ediyorum. Çalışmalarında başarılar diliyorum. İnşallah yakın bir zamanda da kendilerini pandemi sonrası üniversitemizde de yüz yüze ağırlamaktan da büyük bir memnuniyet duyacağımı kendilerine iletmek istiyorum.
Teşekkür ederim. So our vice rector, Professor Dr. Las Çaydaş, he also thanked you for your valuable speech, and he's agree with you with kind of brotherhood. Pakistan is our brother, and he also would like to invite you, especially in Turkey, specifically in this area, as I already invite you, and giving like kind of face-to-face speech. And yeah, he's very appreciated for your speech, and we also would like to see you here too, Dr. Farhan. And I think it is very related, Doctor, because our vice rector from mechanical engineering base, so he's always had this kind of projects. As you know, we have CAI and IHA, so it's very important for Turkey security right now. So your work is kind of related, I think. And especially you mentioned about agriculture, these micro drones, which is very important in today's technology. And you mentioned some, of course, statics, which is going to be, I think, our future. It affects enormously. So I would thank you again for your speech, but we really would like to have a question, as we have a lot of academic colleagues here. So I think we have one question here. Let me Translate. Oh, actually, can you read the messages on the right side, Farah? The most of them I appreciate for your speech. So if there is no question, can I ask a question, please, Farah?
Yeah, sure. And
as I said from the beginning, it's not my area, but I would like to ask you 2 questions. So first, what's the most challenge factor when you design these Dopplers or micro drones? Specifically, it is power loss or is noise, because you're using kind of transmitter or receiver, this kind of stuff. So there is a lot of noise and other factors which affect the accuracy and then etc.
Yeah. The biggest challenge for that is that the conventional radars are not designed to detect them, right? So they are designed to detect a costly aircraft, but they are not designed to detect a very a cheap hobbyist object that's just flying around you, but that is a threat to you. So and the reason being, as I said in my presentation, that they have a very low RCS and they fly at a low altitude and at a low speed, and they can be confused with a bird, for example. So you can just detect and you can just say that is a bird, but that is actually a drone or a micro drone. And regarding the hardware, obviously, it should be an interference-free hardware, because the micro Doppler signature, obviously, you're detecting a signal that has a very a knife kind of a signal strength. So you have to take all of these things into account. The good thing is that we don't have a stringent requirement of the bandwidth that usually have for the radars, and by that we can exploit that and make use of that thing in your favor. Yes. And then one more thing I would, regarding what you said earlier, I would like to thank Vice Rector for the invitation. Thank you very much, sir.
Okay. Ulaş hocama da kendileri teşekkürlerini sunuyor, sizin de anladığınız üzere. So the second question was about so I really impressed about what is the cause of generating sinusoidal signal when the Doppler is activated. It's very strange for me and also is surprising me. So like the example in the bird, so when the bird is kind of doing the wing, so is it because of the power at that side or something else?
No, that is because actually that movement usually is sort of something that is vibrational, sort of something that resembles a vibrational movement. And that vibrational movement, when you're going to solve that, it comes out to be sinusoidal at the very end. And that is what you have seen in the corresponding short-term Fourier transforms. It turns out to be something that looks like a sinusoidal pattern. So if the corresponding effect of the non-rigid part of the body is something that resembles a vibration, so it would turn out to be sinusoidal at the very end.
Okay, thank you very much. And any question, please?